All right, this is the third lesson of the second unit on quadratics. So specifically with this lesson, we will be talking about the quadratic relation y equals ax squared. So the first thing we're going to do is look at our base graph. So our base graph is always going to be the same, always going to be y equals x squared. Okay, so that is a parabola in standard position, or like I said, our base graph. So essentially what it is, it's our starting point. Okay, it's the graph that we are going to be applying transformations to. But the first thing we need to know is actually how to graph this base graph or the parabola in standard position. So when we are graphing, we're always going to be using the same x coordinates. So we're always going to be using coordinates from -4 to 4. Obviously just the whole numbers to make it easier on ourselves. Okay, so we're given those x's, or we know that those x's are between -4 and 4, and we need to find our y. So to find our y, all we're doing is we're using substitution. Okay, so what this is actually saying is just to sub in x equals -4 into our equation to solve for y. Okay, all it is substitution. So we're going to go through and figure out the coordinate points that helped us make the parabola that you see on the right here that's already been graphed. Okay, so we have, instead of x, we're going to write -4. And again, putting that in brackets and then typing that in on your calculator. So -4 squared is 16. So that means we have the point -4, 16 on our parabola. Okay, and we're just going to do the same thing continuously. So here we have -3 squared is 9. So we have the point -3, 9. Again, just replacing that x with the value that it gives you. So -2 squared is 4. So we have the point -2, 4. -1 squared is 1. So we have the point -1, 1. 0 squared is 0. So we have the point 0, 0. 1 squared is 1. So we have the point 1, 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. Okay, so just a reminder about exponents. Remember, this is not 4 times 2, right? It's not 8, it's 16. It's 4 times 4. 3 times 3. 2 times 2. Okay, that's what that exponent is telling us to do. Okay, so if we look over at this graphed parabola, we can see that all of these points are on here. Okay, so we have 0, 0. We have -1, 1, 1, 1, -2, 4, 2, 4, -3, 9, 3, 9, -4, 16, and 4, 16. So when I plot those points, I can see that they're all on my parabola, right? So in order to draw that parabola, that's what I would do. I would plot those points and then connect them with a line. All right, and I am just going to get rid of those to make our graph clear for more points. Okay, so that, again, that is our base graph. That is always our starting point. So look when we have an a out front of that graph. So if we're graphing y equals ax squared and a is positive. So the key there is that a is positive. So we have 4 different tables here. We're going to complete each of them and then sketch each of those on our axis above. So on that same graph that we have our base graph, so we can kind of see how these different values affect that original graph. Okay, so in the same way as we did above, we are given our x, right, -4 to 4, and we need to plug them into our equation. So these equations all differ, right? We have 1/2 x squared, 1/4 x squared, 2x squared, and 3x squared. So if you don't want to deal with these fractions, you can just use decimals, right? So this would be the same as y equals 0.5x squared, right? This would be the same as y equals 0.25x squared. And that is fine. It's going to be easier for you if you do use those decimals, because you'll be able to graph it a bit better than if it was a fraction, right? We just seem to understand decimals a little easier. So again, we're going to do the same thing. We are going to take our x and plug it in and figure out what our y would be. Okay, I don't have that middle column, so I'm just going to simply do that on my calculator. Okay, so on your calculator, you might be able to just type in 0.5 bracket -4 bracket squared, and it might give you the right answer. Some calculators will not work that way, so what you might want to do is type in -4 in brackets, square it, okay, so you'll get 16, and then multiply that by 0.5 to give you 8. So this coordinate would be -4, 8. Okay, like I said, some of you might be able to do 0.5 bracket -4 bracket squared, and it will give you the right answer. But some calculators just don't follow BEDMAS automatically. That's why it's sometimes better to just do it in a couple steps on your own. Okay, so again, this is just simply substitution. So we're substituting -3 in for x. So we have -3 squared, which would be 9, times 0.5 is 4.5. Okay, -2 squared is 4. 4 times a half, or 0.5 is 2. -1 squared is 1, times a half is 0.5. 0 squared is 0. 0 times anything is 0. 1 squared is 1. 1 times 0.5 is 0.5. Come on, there we go. 2 squared is 4. 4 times 0.5 is 2. 3 squared is 9. 9 times 0.5 is 4.5. And lastly, 4 squared is 16. 16 times a half is 8. Okay, so we have all of those coordinate points. So we're moving on to the next step, which is to actually graph that. So just like I showed you before, in order to graph it, you're just plotting these points and connecting them with a curved line. So we have -4, 8. It's going to be there, 8, 9, 10, yep. -3, 4.5, so this is going to be between 4 and 5. Okay, -2, 2. Come on. -1, 0.5, so between 0 and 1. 0, 0, and then we have symmetrical points going up the other way. So you can continue to graph it. You can go 1, 0.5, or you can just make your points symmetrical. Okay, so making sure that they look the same on both sides of those axes. Okay, once we've done that, we're going to connect them. Again, bear with me, mine is not going to be perfect. Whoa. Something like that. And something like that. Okay, not bad. So again, keeping in mind that we're taking that line that we can already see and we're adding a transformation. That's what we're doing. And our transformation gives us this new orange graph. Okay, so we're going to do the same thing with these other ones, just for the sake of time, guys, just because I don't want you sitting here for so long. We are just going to do 2 of them. Okay, so if you think you need more practice, go ahead and fill in those other 2 charts, but together we're just going to do 2 of them. So we're also just going to do 2x squared here. Okay, so we're not going to do this one, and we're not going to do this one. Again, just for the sake of time. Okay, so again, we're given our x coordinates, right? And we're given an equation. This time our equation is 2x squared. Okay, so we're just using substitution. Instead of writing x, we're writing what it tells us to in our x column. So this one we have -4 squared, which would give us 16 times 2, which is 32. So we have the point -4, 32. Okay, same thing with -3. -3 squared is 9. 9 times 2 is 18. -2 squared is 4. 4 times 2 is 8. -1 squared is 1. 1 times 2 is 2. 0 times anything is just going to be 0, right? So this is always just going to be the point 0, 0 for when we have y equals ax squared. Okay, 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. 3 squared is 9. 9 times 2 is 18. And 4 squared is 16. 16 times 2 is 32. Okay, so again, we got those points by simply subbing in these x values into our equation. Okay, and our next step is to graph it. So I'm going to pick a different color here. I should have just done that all in green, but that's okay. So now I'm going to plot my points. Obviously, this scale only goes up to 16, so we might not be able to plot all of these, okay, but we'll be able to plot a good solid 5 or 6 of them, so we will be able to kind of see, or not even, 1, 2, 3, 4, yeah, 5 of them. Okay, so we're not going to be able to plot -4, 32 because our graph doesn't go that high. We're not going to be able to plot -3, 18. Again, our graph doesn't go that high. So we're going to start with -2, 8. So -2, 8, and I'm just going to put a point there. -1, 2. I'm going to point there. 0, 0. 1, 2. And 2, 8. Okay, so again, I can't plot any of the other points because they are too large. So I'm going to connect these and see my new parabola. Okay, so now we can see 3 different parabolas there. So let's look at those a little bit. So from our base graph, which again is the black line here. Okay, our orange graph is y equals 1/2 x squared, and our green graph is y equals 2x squared. Okay, so when we have a decimal or a fraction, we can see that from that original graph, we get kind of wider, right? It looks a bit fatter. Okay, they're coming out wider. When we have a whole number, right, that's greater than 1, or a positive whole number, we can see that from that original graph, we're getting skinnier. Okay, so we're going to summarize this down here. So, go back to my orange. So when a is positive and a is less than 1, the parabola opens up and is compressed. Okay, it's going to be compressed when we are less than 1. If we are greater than 1, we're still going to open up, okay, but we are going to be stretched. Okay, so when we're compressed, we appear wider, and when we are stretched, we're going to appear narrower, right? Imagine pulling it up or pushing it out to the side. So this type of transformation is called a vertical stretch or compression. Okay, and we are able to visualize that. So you can see that we've pulled our green graph up, it's appearing skinnier, and we've pushed our orange graph out to the side and it is appearing wider. Okay, so that's the first half of the note. Okay, we don't want to do that. No, go away. not the one. Here we go. Investigation 2. All right, so this is the back side of your note, or the second half of your note. So again, you can see we have a set of axes on the side, and we have already graphed one of them. So it says graphing y equals ax squared when a is negative. So that's where it differs from the last one, right? Our first investigation was just when a is positive. Now we're dealing with a is negative. So it says complete the table of values for the parabola y equals negative x squared. Oh, this is going to keep doing this. Sorry, hang on a sec. Of course. Okay, if it does it again, I will pause the video and make a part 2 here. All right, so like I said, we need to fill in this table to figure out what points are on our graph of y equals negative x squared. So again, just substitution, right? You're taking that -4 and you're plugging it into your equation. Okay, so when you do that, you're going to plug it in brackets. So negative 4 squared is negative 16. Okay, and again, on your calculator, you would do -4 squared, which would give you 16 times -1, which is negative 16. Okay, I am going to stop this video and do a part 2 so that this will stop popping up.